Hello, everyone. Good morning or good afternoon, or even good evening, where you are. We are again joined by Imran to do dependency scanning lab today. As usual, we're going to have a theory part where he will explain to us what it is about, and then we will have a lab. So this is the second week of the training sessions on Open Security Summit. We will have the actual summit next week. I hope you are all enjoying it, whether you are here with us now or catching up on YouTube later. So Open Security Summit is a very, very collaborative environment. Normally it happened on site, but this year everything is virtual, and that means we went global as well. We have many different participants from all around the world, and it's quite good. I feel like some of you guys have become my friends in these last 2 weeks. We do expect participation in the session and challenge Imran. He's very open to challenge, and he gets bored if we don't challenge, so we should really ask questions whenever we have them. And don't be shy. You can unmute yourselves and ask the questions, or you can post in the chat, and I will be monitoring that as well. So everything about the summit is open, and we do record the sessions, we do record the outcomes, and check back the website in a couple of weeks and you will see all supporting documentation as well as the videos. The videos get uploaded to YouTube within 24 hours, but as I said, the website will have the videos and supporting documents as well, so you will be able to redo, or not redo, but follow it deeply, to a deeper level. And respect. This community is a very diverse community, and we wouldn't survive without the diversity. We all need each other, and we are here to learn from each other, so just be nice. OSS 2020 is our hashtag for this year. Please use it generously. Let the world know how it's going, and let us know as well if we can improve anything for next year. And I will be posting our Slack community invite in the chat window in a minute. If you're not on there, come join us. The conversation goes around all the year, not just during the summit, so you can continue learning, you can continue communicating with the rest of the community. And that is me, and I'll hand over to Imran now.
Yep. Thank you, Dida. I'll share my screen. Let me know if you're able to see it in the chat.
Yep.
Okay, so just like before, a couple of rules of engagement. I would like to keep this session interactive, so please do share your question. If you're shy, use the chat function. If you would like to speak, then please feel free to unmute yourself and then speak, right? And as Dida mentioned before, I don't like to, talk, and then there's no interaction. So I would definitely ask questions in between, pause in between, and then take questions and then move on. So please, let's try to keep it engaging so all of us can benefit. Okay, so let's get started. So as Dida mentioned, we are a training partner, our sponsor for Open Security Summit this year. We help people learn DevSecOps. So our trainings are usually pretty hands-on. You would see a gist of that today. And they are also pretty role-based training. So based on what you do, we have different kind of training. And then as you will see an example of our platform, which I'll give an introduction about in a couple of minutes. It's pretty scalable as well, pretty interactive, pretty easy to use. So you can learn everything related to DevSecOps in there. And the part of training today you are seeing is part of our Certified DevSecOps Professional course, but we do go in depth into a lot of other aspects of security, like Expert, Architect, and Leader course. Feel free to check out if that's something of interest to you. So I'm Imran. I'm the founder of Practical DevSecOps. I've spoken and trained in different conferences like Black Hat, BruCon, DevSecCon, a bunch of other conferences and whatnot, on specifically on DevSecOps. Okay, so let's get started. Now, before we get started, can let me see where you guys are from. I see a lot of familiar names, so I definitely know where you are from, what you do, what your background is. All right, so John, for the folks who are new to this one, could you please unmute yourself or type it in chat? What's your experience in terms of where are you from? Canada, okay, that's great. And then what do you do? Are you into ops, security? Yeah, so what do you do? Okay, security engineer, great. Cloud security, it's great to know. Security as well, pretty good. Great. So some of you are also from DevOps, that's also pretty good. Software engineer, great. Ah, hooray, we have someone from DevSlop team, OAST DevSlop team. Pretty good.
Yeah, I really like
Glad.
your sessions as well, DevSecOps team. Go. Very good.
Yeah, definitely. Yeah, that's good to know. Okay, someone from Berlin, pen testing, awesome. Great. Information security. So it looks like most of you are from security, a couple of you are from software engineering as well. So that's good. So I think, how many of you know what is DevSecOps? So that I don't, repeat the whole session again, like I did yesterday. Just say yes or no in the chat if you know DevSecOps. Yeah, okay, great, 1%. Okay. Okay. So what I will do is I will just quickly summarize what is DevSecOps, and then we'll move on to the session. Okay. Now, when I talk about DevSecOps, people usually assume, oh, it's all about tools. You have to use Jenkins, Travis, GitLab, Bitbucket, bunch of tools, fancy tools, and you have to spend few millions to get any benefit out of it. Right? That's how typically people view it. But then I'm sorry to break your bubble, but that's not what DevSecOps is all about. It's definitely not about tooling alone, right? Probably tooling is 1/4 of the entire DevSecOps practice. So it involves culture. It also involves measurement and sharing best practices, learning from our mistakes, continuous feedback, and whatnot. So you have these tools, but then you don't have to know everything. Again, as I mentioned yesterday, if you know Git, then probably you already know GitLab, Bitbucket, and GitHub. Fundamentally, they use Git. So if you know this, all of those tools will make sense to you. Similarly, CI/CD systems are almost identical to each other, except the UI is a bit different. Some features are different, but more or less, they allow you to do something very, very similar. Okay, so don't let these tools scare you. And again, as I mentioned, if I'm repeating again, DevSecOps is not about tools. Okay, it's more than that. It's people, processes, technology, and that order matters, right? So ignore this, let's go on. And one of the problem with while implementing DevSecOps you will face is that security is left behind, because security is in general considered a department of no, because we think that everything is going to be get hacked, which eventually is going to get hacked. But then a lot of things matter way before security. What do I mean by security? Imagine you are working for a company and their job is to create software for customers, whatever that is, business customers, end users, whatnot. So they create customers. Security is important for sure, but staying in business and doing business is far more important than securing it at first. Okay, that's predominantly why even startup companies, they don't have anyone dedicated working on security probably till they hit like 40 and 50. Again, as I mentioned before, I'm not saying security is not important and you should not do it kind of thing, but I'm saying security is important, but then staying in business is far more important. What do I mean by that? For example, um, if you don't have any business, then you will not have jobs either, right? So they want to make sure you as a security engineer is trying to secure their infrastructure, application, and whatnot. So all we have to do, security has to think about, is from business perspective. What can I do to reduce risks to the business, be it technical risk, operational risk, or whatnot, even security risk. Security is one aspect of the risk management methodology of a business, right? So we have to ensure that whatever decisions we are taking, we are keeping usability in mind and the business constraints in mind. And I can give you another example in this aspect, which is, let's say you have a vulnerability, and then in order to fix that vulnerability, it will cost you $1 million. But then if you leave it as it is, then it might cost you about $10. Let's imagine that, right? If you leave that vulnerability as is, it might cost you $10. So you have to, now, would it make sense to save $10? You are going to spend $1 million? Probably. Like, you might want to even spend $1 million even with that loss of $10 because of goodwill, right? So you have to make that decision about it. But security is usually, they look at the security from a technical angle, which is not the whole picture. So we have to think about people first, and then put in processes, and then technology. So technology is what you are all interested in. So we'll talk about that as well. So I'm just going to quickly skip this because most of you have seen this before yesterday. So what I'm going to talk about is that we had problems with traditional waterfall model because it was too slow, too cumbersome, too expensive, and ultimately the customers were not too happy with it, right? So in order to solve this wall of uncertainty, like I like to call this wall of uncertainty, people started exploring different kinds of activities. Agile is one of them, right? In Agile, instead of waiting for like 6 months and a year or 2 years, you continuously iterate and correct your course. My assumption, according to customer, is this: does it still hold true? If it not, then you scrap it. Otherwise, you can continue on it, right? So that's what happens. Now, because of Agile, now developers are pushing code to production every 9 seconds. What happened was that the operations became a bottleneck, and they were unable to cope up with the amount of work developers were sending to operations team. So in a way, history repeats itself. So the lessons which operations teams have learned, we as a security has to learn that now. Okay, so that's what we'll see. So now developers were pushing code very rapidly, and then operations teams could not cope up with it. And then developers want more and more features going to production. Operations teams, they want to keep our infrastructure safe, secure, and stable, right? So now you see these people, two people are trying to do different things. Our two teams are trying to do different things, and that's why there was a lot of friction between these two teams. And because of that, they started to see how can we reduce this friction and work with each other as a team rather than two different entities. So then they started talking about how we can solve it. One such methodology to solve this problem is DevOps, right? As you can see, it's a software engineering practice that aims to unify software development and operations, right? So that's what DevOps is. And by definition, it allows you, so actually, if you look at it from waterfall model, this is just a reiteration of waterfall model. Instead of saying design or requirements gathering, planning, they just call it plan. Instead of calling it implementation, they call it create. Instead of calling it testing, they say verify, right? Release is similar to that. Monitoring is your typical monitoring. The words have changed, but the technology, the process is same fundamentally, right? But then there are some extra steps which are added here. How do we measure? How do we share these best practices and whatnot? Now, so operations and developers, they have become friends now. And then security is the last transformation, digital transformation, which we have to overcome in order to create a complete DevOps pipeline or complete DevOps to digital transformation, right? So in general, like as always, security has a love and hate relationship with the rest of the organization, because probably security is considered as a blocker. They don't let DevOps team innovate at a faster pace. That's why some people look at it as like, oh, nerds, introverts don't like to work with anyone else in the organization. Whereas if you follow the best practices in DevOps or DevSecOps, we'll be able to even though you are introvert, even though you don't like to interact with people, you will still be able to keep if not everyone, at least a lot of people happy the way you do security, right? So what I want to say is there are a couple of problems the way we do security at the moment. One is that no matter how good you are as a security engineer, you cannot scale or compare to 100 developers. And this is a typical ratio we see in the organizations. For every 100 developers, we have one security engineer, right? So if 100 developers are pushing code to production every day, we also have to do pen testing every day, right? We also have to do source code review every day. But do you think a one person can cope up with the amount of work they are sending to security? Probably not. And then ops, as I mentioned before, ops were also in a similar situation. We can learn a lot on how they solve those problems. So we can copy those aspects, whatever works in security, and copy those and implement it in an organization. That's what the whole idea of DevSecOps is all about. Can we learn from DevSecOps? Implement application security, monitoring, network security, whatnot, threat modeling as part of DevOps or DevSecOps. So that's what we are going to learn today, right? And if you notice the definition of DevSecOps, I didn't say DevSecOps, I started with DevOps. And I believe when people were talking about DevOps, security was there as part of ops, right? But you would be surprised, my company name is Practical DevSecOps, right? Why did I use that? Because more and more people are looking at DevSecOps as a way to achieve education or awareness about, hey, we have implemented DevOps, we should also think about security, right? And because we were very, and when I say we, I meant security. So we were very rigid in the way we work, so we were left behind. So right now is this initiative called DevSecOps. Is a very nice initiative to bring that discussion in DevOps, which is that we need to consider security also as part of DevOps, right? If you do that, we will achieve these benefits. Your system will become secure, and you can secure your infrastructure at a very fast, at a very, at a very, on a very, lack of a better word, on a very competitive way, right? You can probably secure a vulnerability every 9 seconds since you're pushing code to production every 9 seconds. Previously, what used to happen was that if you want to fix a vulnerability, then the entire system needs to be built, and then it used to be deployed to production. It used to take anywhere between 6 months to a year. So if you have to fix a bug, you have to wait a year or 6 months. But that's not the case with DevOps or DevSecOps. So it will also make your systems resilient. It will also make your systems reliable. It will give you a lot of flexibility. You will be able to sleep peacefully in knowing that your DevOps pipeline, your DevSecOps pipeline is taking care of baselines, minimum base security baselines, and then ensuring that you get a good night's sleep. Similarly, it will help you achieve automation, static analysis, dynamic analysis, compliance, hardening, whatnot. And as I mentioned before, if you want to do DevSecOps, you have to do these four things: culture, automation, measurement, and sharing. Now, if you come to me and say, hey, we do DevSecOps, and then the first question I usually ask is that, okay, what do you do as part of DevSecOps? Usually my answers would be, okay, we embed static analysis here, dynamic analysis here, and then pre-commit hooks here, and hardening, we do hardening here, compliance. I was like, okay, what else do you do? And then they end up saying that, that's it, that's DevSecOps. Sorry, sir, because if you don't concentrate on culture, measurement, and sharing, no matter how much money you invest in automation, it's not going to help you out. And that's a sad reality. So you have to work on culture, building culture. Security Champions is a great way of creating that culture. And then you have to create a way to measure security. Like, how do you measure how well are we doing from a security perspective? Similarly, we have to share these best practices with developers on, okay, this is how you run static analysis tools. These are your false positives. This is how you fix it. That's wherein you also see security awareness training, developer training, and whatnot. Some people do it because of compliance, but you have to do it to build culture in the organization, okay? So that's there. I'm just going to skip all of these for now because you've already seen this, most of you. Okay, so let's talk a little bit about the lab, okay? The lab we're going to use today. Okay, I have one question here. Let's take that question. Okay, no question. Fair enough. So today, all of you are going to use our online platform, which helps you learn DevSecOps, Docker, Kubernetes, compliance as code, static analysis, dynamic analysis, what you have it. Basically, you can learn entire product security, application security on our platform. And we have exposed a couple of exercises for you. These are some exercises as part of our courses, not the whole picture. But let me show you a demo of our platform first, and then we'll go into see how you can use it. Now, if you joined us just now, you have to sign up for our platform. The link for that is here. I'm just going to share that link in the chat. So please head over to this link and click on the sign up button at the header, which is available in the header, and then use the email sign up link. So I removed the LinkedIn and the Google and the Twitter SSO deliberately. So please use email sign up. You'll get an email confirmation. Please confirm your email ID. Once you're in, you can log in. Once you log in, you have to go to the courses page. Okay, I'm just picking one among them. We are going to do 2 exercises today, probably 3. SEA, software component analysis, which is also dependency scanning using Retire.js. We will also be using safety, and then we'll do these exercises. So let me show you a platform a bit. So you click on the start link, and then this will give you what, explain you what we're going to do today. So as you can see, we're going to run a static analysis tool called Bandit. And in order to start this exercise, we're going to just click on the start exercise button here, and it will open up a remote machine for us. And then this is where we will do the entire practical labs. And you can open this in your iPhone, iPad, and whatnot. It works across all browsers. You just have to have a browser available. You can, as I mentioned, you can even do it in an iPhone, right? So then there are a couple of steps. Anywhere you see that there is a reddish or pinkish text, it's a command. So if you click on that command, it gets executed. As you can see here, it got executed here, and I didn't copy paste it. Okay, I'll show you again. And then we are going into a directory. Once we are there, we are going to install Bandit, which is a static analysis tool. Okay, that was already installed. And then we're going to look at how this tool behaves, what are the different options you can use to embed this as part of CI/CD pipeline. And then finally, we are going to run this scan. And I'll explain you what's going on in each of these. As you can see, okay, the scan ran, and it created a file called bandit output. You can check that out. So it's vim bandit output. You see that? And then there you go. There is a one medium vulnerability, medium severity vulnerability. There is another vulnerability, which is a medium, which is pretty interesting. And there's one high severity vulnerability. That's pretty good. Yeah, that's pretty much about it. So we got 3 vulnerabilities here. We'll see what we can do with these vulnerabilities, how you can make best use of this thing. Now, a quick suggestions here are best practices. If you think your system is stuck, or you got this message saying that, hey, your connection is closed, or if you think that, okay, something is wrong, all you have to do is just refresh this page. That's it. Everything would be back to normal. Don't worry about what you did in the exercise. You can, again, click start the button, and you're in the platform. And then you can just go through the exercise, next, whatever, finish and done. So that's how the platform works. So we will be doing a couple of exercises here today, as I mentioned before. We will be doing Retire.js. We will be using safety. Now, you might have a question here, like which I got a lot yesterday, is that do I need to know a specific tool in order to implement DevSecOps? And the answer is no, you don't. Because if you look at, we teach organizations across the world, right? So some of them use Java, some of them use .NET, some of them use Python, Ruby on Rails, what you have, right? Like Golang, whatever, right? We also have customers who still use C, an old version of C. ANSI probably 90 version. We also have some customers using Lisp and whatnot. So no matter what language you use or what technology you use, you can still get benefit out of DevSecOps and implementing DevSecOps. So the tooling does not matter because there's definitely some other tool available to help you achieve this. Some of them are open source, many are paid. So you can either consume the open source versions or you can also consume the paid ones as well. So whatever you end up picking up, you can do DevSecOps. As long as you have a CI/CD pipeline of some sort, then you can do DevSecOps without any problem. Any stack, that is, be it Azure DevOps, AWS, GCP, on-prem kind of a solution, OpenStack, Kubernetes, on-prem installation, whatever you have, you can do DevSecOps, right? So again, if you're reiterating this, technology does not matter because once you learn fundamentals, you can apply this across the board. Okay, so let's go back and then discuss what kind of lab setup do we have here, right? And again, you don't have to install anything. You don't have to run any commands. Everything is a browser, works behind firewall and whatnot. Okay, so we have a couple of machines here. Specifically, we have a machine which you see, but we also have a GitLab machine, which you are not seeing there, which is every one of you will have a machine given to you with this unique ID. So this is a GitLab machine. So you can log in. So my colleague Yuga will share those URLs with you. Okay, so I'm going to log in with the username and password we have set up. It would be shared again as part of the process. Yuga will share those credentials. So eventually, by the end of this presentation, we will be able to create a CI/CD pipeline, and we will embed Retire.js, Band-Aid, and any other tool available. And every time a developer pushes code to your code repository, we will be able to do DevSecOps on that code base. And we'll be able to catch any vulnerabilities in the code itself and before it goes to production, right? So that's what we will achieve today. I hope that makes sense to all of you. Does that? And were you all able to access the portal, sign up to the portal? I need confirmation, otherwise it's difficult for me to get.
With portal, I'm fine. This GitLab machine, that is separate,
yeah,
right?
Yeah, that's separate. Yeah, so it's created behind the scenes for all of you. But yesterday we had some interesting problems with it, so we are doing this today. I don't want to disclose what, but yeah. So again, in the platform, in our production platform, you click on this one, it will set up all of these machines for you. So as I mentioned before, it will set up all of these machines for you behind the scenes. You can just access those machines. Okay. Yeah. Are you able to sign up? Let me see. So we have about 25 people here. Let me go back and see how many of you have signed up for this.
For the training GitLab one?
No, not just the portal.
Just the portal. Okay. Yeah. I'm good to go with that one.
Yeah.
Do we need to use the other one? I'm a bit confused.
No. So I see about 12 people, right? So what are we waiting for? Like, you don't want to do the practice? If so,
so
I can wait. Yeah.
So I'm on the portal, but the
Sure.
the GitHub, where is that?
Okay. So once again, can I have all of your attention now? Okay, that's good. We will give access to GitHub via DM. So you will be able to receive message from my colleague Yuga to specific every user. Okay, you will receive it. We are not going to leave you behind. We will take you along with us, so you're not missing anything. Okay, so we'll give you access to that machine. Hold on a minute, yeah. Okay, sure. If you're not able to do the practice, that's fine. You will have access to this portal for a week from now. So that's fine. So I'll probably spend 5 more minutes. I'll let you sign up. The link for sign up is in the chat. Click on there, go to the sign up. Use email form there, not the SSO.
I'm pausing the recording.
Okay. Now that our labs are set up, which is basically signing up for a portal, and as part of this, every one of you have a Git server, and it's dedicated only to you. No one else is using that system at the moment. And then there's a GitLab CI/CD system in there. We'll be using that to create pipelines, DevOps pipelines. And then there is a runner, which is basically is going to run your scans on, right? That's a system where you will run scans. And then you also have a prod machine. At the moment, we are not going to use these at the moment, but yeah, right? So there's a GitLab machine, as I mentioned before. This is where we will store our store our code and also do CI/CD. This is where your specific tasks will be run, and then you have a prod machine, all right? So basically, this is what you have there, right? You have a couple of boxes spinned up again every time you click on this button, right? So all you have to do to set this up environment is just click on this button, right? Start the exercise, and everything is taken care automatically for you behind the scenes, right? So there you have it. So we'll go through each of these step by step. Okay, so the next thing I have for you is, let's talk about component analysis, also known as software component analysis, also known as dependency scanning. I like to call it as open source application security testing. It fits nicely with static analysis, SAST, DAST, RAST, IAST. Right? So yeah, it's a made up term. There's no such term called OAST. It's called a software component analysis, dependency scanning. So what is it, right? Why do we want to embed this as part of a CI/CD pipeline as our DevOps or DevSecOps pipelines? And then I'm going to use these terms, DevOps and DevSecOps, interchangeably. So when I say DevOps, it means it includes DevSecOps. And when I say DevSecOps, it includes DevOps as well, right? So the software component analysis testing allows you to test for open source or third-party components which might have some vulnerabilities, right? A typical example of this is your Equifax hack, which basically they got hacked because of a vulnerable structs component they were using, an open source component they are using, right? So our job is to make sure that we are not using any components which are vulnerable to a vulnerability, or if they are, we are going to update them. If they don't have any updates, probably we'll find some alternative package, right? It's not always possible to find an alternate package. Then probably you're going to use something like virtual patching, firewall, and whatnot. Right? So there is some way of doing. Again, the risk management, risk assessment, threat modeling comes into play here. What you're going to use to mitigate the risk depends on your specific context. Now, when it comes to the strengths, it's very easy to get started, and we recommend our clients that this is the first test they do when it comes to implementing their DevSecOps pipeline. But when it comes to weaknesses, all they do behind the scenes on top of a fancy UI is that they do compare the checksums they have of vulnerable components against the components they find in a project. And if they match, if they have a match, then there's a vulnerability. And then they can then show you information. Okay, this is the component you use. This is a version of the component you use, and it has these vulnerabilities or one vulnerability. You need to bump up this version to so-and-so version to fix that vulnerability. That's what these tools, component analysis tools, do. So if we have time, I will show you. Okay, yesterday, as I showed you guys a lot of demos on how to do security in DevOps pipelines using open source software. Now, someone reached out to me on Twitter and said that, okay, Imran, this is awesome that you're showing open source tools, but then these techniques don't fit into CI/CD pipelines or with the paid tooling. Then I said, okay, buddy, come back tomorrow, and I'm going to show you a paid tool. For this today, that would be SNCC. It's a tool to do SCA, dependency scanning. I have no relationship with them. I am not recommending them, or I have nothing against them or with them, right? So this is purely from a perspective of showing you a demo of Snyk. I can also show you a demo of another tool called SourceClear, which got acquired by Veracode. Again, no affiliation of whatsoever. I just think they have done pretty good work. So I'm going to show you a demo of that, right? And we're going to use their free trial version. So all of you just have to log in and then use that version. Again, not to promote them, but to show you that the techniques which we are teaching here in our here and also in our courses apply across the board, both to free tooling and paid tooling as well. Coming to threats, these tools can give you false positives. And if you are failing the builds based on this false positive, you are in for a rough time, buddy, right? Whatever that is. So let's say imagine the developers are trying to push a critical fix to some bug, and then you block them because you found a vulnerability and it happens to be a false positive. What would be a reaction of your developers? They will be really, really pissed off, saying that, okay, you are using false data and then blocking our builds without verifying. So you have wasted or blocked my build from going to production, which was very, very critical. So it's a grave sin. So we have this concept, kind of a material called DevSecOps Gospel we teach, wherein the first sin, grave sin of DevSecOps is blocking your build in maturity level 1 or 2. Right? You're not supposed to block your builds until you have confidence that there are no false positives, or you have trained your developers to get rid of false positives. Right? Till then, you should not, and you will not fail the builds. Okay? Probably you should promise, give me an oath, everyone, saying that I will not fail builds till I get rid of false positives. Right? You can give me a pledge there on that. Anyways, moving on. So that's the threats, right? Can be sometimes pretty vague and very difficult to pick vulnerability. Sometimes vulnerability could be in the component itself, or it could be in a dependency of a dependency and a dependency. I like to call it transitive dependencies. So it's not in the direct package you use, but the package of a package of a package. Now, would you fix that? The one dependency problem in dependency of a dependency or in the direct package. So it's up to you. Again, risk management comes in here. What do you want to do with it? Is it a significant risk you want to fix or not? Up to you. Okay. Now, these tools, if you know internally developed component and they have vulnerability, these tools will not know about that. Or if you have compiled yourself a package like an OpenSSL or Nginx, they will not be able to find such vulnerabilities either. Okay, so you have to be very, very cognizant. And some of these, when some of the SEA vendors, what they also do is, apart from doing SEA analysis, which is a form of static analysis, they also scan the code to figure out, are we using the vulnerable function of that third-party component to see if we are vulnerable. If not, then probably we can ignore it, right? So that's something, yeah. So something you can do there as well, okay? And when it comes to SEA, you can do SEA of operating system components, which is what one is also known as vulnerability management, right? You can also do it for internally developed components, third-party components. And as I mentioned again, I'm reiterating this point very specifically. Technology does not matter, tooling does not matter, because you have, for every tool or tooling or technology, there is some sort of dependency scanner for that, some sort of it, right? So it's available. You don't have to pay someone millions of dollars to do this. You can start right away, okay? Sure. You can also do it for containers. Again, when we are scanning containers, we are looking at, are we using any software which has vulnerabilities, right? Be it Telnet, FTP, and whatnot, and making sure that we are failing builds based on that data. Now, another problem which these components also solve, or this technology solves, is we might use packages which might sound pretty similar to each other. For example, if you look at here, right? Yeah, you have a package here called acquisition, right? You see this? Sorry, here. Is it spelled correctly there, or is it missing a letter or so?
Yeah, it is missing an I.
Yeah, it's missing an I, right? Similarly, if you look at it, Yeah, there's no such thing called Django server. It's just Django, right? And yeah, you see here, there's another thing, URL lib. Are we missing some letter there? Yeah, we are actually missing.
Yeah.
Now,
No.
so
Maybe in the ones at
yeah,
the bottom.
correct. So there's a lot of problems. Like people are trying to con you and do funny things. Now, interestingly, close to few millions to few hundred millions people have downloaded these new packages, thinking they are genuine packages. Imagine that. And then some of them transfer your passwords to a remote service, or some of them start crypto mining on your infrastructure. So we have to be very, very careful that when we are using open source software components, we are scanning for these vulnerable components, right? Okay, so this is one of the problem to this one. Now, as I mentioned before, every tool provides you some sort of dependency. For example, if you're using Python, you have safety. If you have Java, we have amazing project on open source called OAST, called OAST Dependency Checker. Then in PHP, we have Composer. Ruby on Rails has something called Bundler. Retired NPM has NPM security from version 8 and beyond. So yeah, so there are definitely some tools, right? So no matter what tool you're using, there is some way to manage the dependency. So I have a question here. It says, do all tools also check for dependencies that have been directly checked in and definitely not in a package manifest, right? So some of them do.
Pasted dependencies, is that, or?
Yeah, so basically, if the dependencies are in the code itself, then would it find out? That's what his question is.
Mm-hmm.
Now, some of those tools do, some of these tools do that, but most of them don't. Okay, so that's yes and no. But if you can create that file, the manifest file, then you should be able to scan with these tools. And most of them also want you to install them before you scan. So eventually, they are looking at the installed dependencies on your file system probably to check if the dependencies in the manifest file matches with what you have installed. It's a pretty complicated topic if we go into it. I want to keep it very simple here for the sake of simplicity. But yeah, you can definitely do that. Yuga, you are sharing with everyone. Probably you want to share with one person. Okay. Okay, fair enough. So these are some of the tools. So we are going to see today JavaScript and Python, but these techniques are transferable to no matter what stack you use, right? Be it PHP, Java, .NET, what have you, right? Even Docker containers. So you can definitely do that there as well. Okay, so let's move on and let's see an example of a such tool called Safety. Okay, Safety is an open source tool which allows you to scan for vulnerabilities in Python dependencies, specifically in a file called requirements.txt. Right, it allows you to do that. They also have a paid service. Again, I'm not promoting them. There's a free version that's what we're going to use today. Okay, right. So these are some of the systems you need for this exercise. But for now, we will just run it locally first, and eventually, after an hour or so, we will be putting it into CI/CD pipeline. Okay, that's there. So let's go ahead and then see what kind of features or benefits does Safety provides us. So you can go home and implement this pipeline in your pipelines. Okay, so let's go ahead. So let's log in into our portal, click on this courses page. As you can see, first we're going to look at Safety. So let's look at where Safety is. Here it is, right? So it's part of Safety, vulnerability scanning, OAST. It takes about 10 minutes to finish this exercise. So let's start this. So click on Start. And what we're going to do here is first we're going to install Safety, and then look at different options which it provides, so we can pick the ones which make sense to us and then use it, right? And then finally, we will be able to store these results somewhere, so we can probably put it in a system like ThreatFix, Defect Dojo, and whatnot. Okay, so let's do that. So I'm going to start the exercise. And as you can see, as soon as I did that, I got a prompt. But the first thing which we are going to do today is we're going to copy the code from our repository. All you have to do, as I mentioned before, to the folks who just came in, we just have to click on this link and it will automatically be executed here. You can very well type it here, like saying that echo PDSO, right? You can also do this if you want. This is not to make you lazy, but to keep the exercise pretty interactive, easy to get started. And as I mentioned before, if you're doing this exercise on a mobile phone, an iPad, it's pretty difficult to type in. So that's why if you click on this button, it will help you run that command. Once again, we are going to go into the CD, into the directory. As you can see, we are in this directory. We have a bunch of code. And if you don't know Python, you don't have to know about it. Okay. As I mentioned again, you don't have to know about Python to learn something today. So next thing we are going to do is go here. And you can do exact same steps on your local machine, right? You don't have to have a platform to use this tools, but I'm just showing you on a platform so that all of you can follow with us pretty easily, right? So the next thing we have to do is we have to install this tool called Safety so that we can scan our Python project and find some vulnerabilities, find dependencies which have vulnerabilities. Click on the Safety, install Safety. Okay, so as you can see, we have already installed this before, so it's going to be the same case for you. And the next thing we're going to do is check what are the different options Safety provides us so that we can use them to scan our project. So let's do that. Let's execute a help command. So as you can see, we have a bunch of options. Let's go through each of this. So it tells us that, okay, if you have API key, you can use PyUp's API key. We don't want to use that. And we definitely want to store results in a JSON file. If you don't want to store it or want to store it in a HTML kind of format, you can use this full report here. If you want to scan everything or only some packages, then you can use this option. If you're embedding this as part of CI/CD pipeline, you want it to be very, very fast. So you can cache these requests to ensure that it finishes within a few seconds, right? Similarly, if you want to scan a specific file of, it's also called manifest file, right? It could be requirements.txt, package.json, gem file, what have you, right? So you can do all of these things here. If you want to ignore a vulnerability, you can use this. As you can see, you can give an ID to this guy. And if you are behind a corporate proxy, which most of you are, you can give it a host, a port, and a protocol, and it will help you do this thing. Okay, so we are running in our lab, so there's no need for us to use all of these. We are not going to ignore any vulnerability because we are not doing false positive. If you want to learn about this, feel free to reach out to me. And yeah, so let's look at that. Let's now go ahead and move to the next exercise. So what we're going to do is we're going to use this command to scan for vulnerabilities, third-party component vulnerabilities in this file. Okay, I will explain you what's going on here, but let me first run this. And I'm going to clear the screen by typing clear command and just click on this, right? There you go. So now what we just did was we scanned this requirements.txt file and it found a bunch of vulnerabilities. As you can see, you have this vulnerability here. There's another one here. And the numbers for each of these change are different. So as you can see, there's a bunch of them, bunch of security issues which are there in this component. So let's go ahead and look at what do we have in this component. As you can see, we only have one third-party component which we are using, which is Django here, right? We are using 1.8 version. So let's go ahead and then check out how new or old this release is. Oh boy, look at that. They released the software in 2015, right? It's not unheard of that we have legacy code in our organization, which is pretty old, which could be couple of years old. I know if you're managing COBOL, good luck with you. Good luck to you. You know, mainframes, they might you might be using a code which is pretty old. They might not be using third-party components, but definitely there is some value in that. All right. So yeah, that's there as well. So we need to upgrade this. Right. We leave this up to you, but let's talk about how we came to a conclusion that we need to do this. Right. So the first thing we do is let's run safety help. Right. As you can see, it provides. So we have two options here: check and review. Now let's do safety check. Let's see what options we need to provide. Okay, so it looks like we ran something and it figured out, okay, we are running this package, but it did not give us the vulnerabilities we were after, specifically the one which are there in the manifest file called requirements.txt. So what we're going to do now is we will explicitly say, I want you to scan only this file, which is requirements. I'm just going to hit tab here, and then it auto completes, and then see if it catches issues. Yes, definitely. Yeah, we have a bunch of these issues here, as you can see, all of this. But then we also want to store this in a JSON file so that we can process it further. As you can see, we have lots and lots of issues here. Then you can probably send it to a different system for further processing, share it with your developers, put it on a CI/CD pipeline, and then make use of this information, right? So a lot of information, it took probably for us a couple of minutes to do this, very hands-on, very interactive, and we just figured it out as we go, right? Now, you might say, okay, can we do this for Ruby code? Yes. Can we do it for Java? Yes. .NET? Yes. Bunch of programming languages, Golang? Yes, we can definitely do that there, right? So pick up what you have there and then start running it. So that's about our safety. Now, what I will do now is take any questions you have. Right?
You mentioned the other languages, but is safety, can we use safety for them, or would we need other tools for those?
Okay, so you have different tools for different languages. As you can see here, we have one for Python, Ruby on Rails, PHP, Java. And if you want to find more, you have this project here done by one of my good friend, Raghu. So you can check that out as well.
Thank
this
you.
link here, for every other language you have, you can check that out. Yeah. Any questions so far? Okay, so I'll take it as a no and move on to the next one. So we are scanning vulnerabilities on a Python code, right? So just that's what we did just now. So what we'll do now is that let's go ahead and scan vulnerabilities in the front end code. So we also use front end languages like JavaScript and whatnot, right? So even some fonts. So we will now see if, right, the front end components are secure to use or do they have any vulnerabilities. We have one such open source tool called Retire.js. So definitely check that out if you're using npm, JavaScript, Node.js to do some kind of development. You will be able to figure this out. Okay, so similar tool. We are going to do one more exercise now, and okay, a quick check. But you now go ahead, spend 5 to 10 minutes going to the portal, right? Go back to the portal here and run this exercise. Go here, click on the safety exercise, start this, and then do this exercise. We'll come back again after 5 to 10 minutes, and we'll pick it from here and then do front end and other ones. Okay, go on now, do this exercise.
DevSlop
rule. Yeah, a big shout out to DevSlop team, Francisca, Tanya, Nancy, and everyone. Who I was Nicole. yeah, so amazing work from them. Please do check out and contribute to the amazing project as well. Okay. Okay, so now that we are done, we are done with this exercise, which is SCA analysis on backend systems. Let's move on to backend technologies. Let's move on and implement SCA scans on a front-end code base, right? You can also use Node.js as a backend language, or if you're just using JavaScript as a way to have interactivity or running small applications, jQuery kind of applications, then you also need to scan for those with the help of this tool called Retire.js here, right? So once again, it's a free and open source tool. And the reason why we have created this is, one, we want to promote open source tools. Two, you don't have to buy a tool to go practice these things in your company or your organization or in your own life to upskill yourself, learn DevSecOps, right? So we are here to help you do that. So Retire.js is such a project. Once again, it's meant to scan JS JavaScript libraries. Now, something has changed with the arrival of Node NPM and version 6. So even in that case, it still provides you value in scanning for front-end dependencies or vulnerabilities, right? And again, as I mentioned before, it only catches known vulnerabilities. If you don't, if there's a 0-day and there is no rule set or there's no logic behind to catch that 0-day, then probably your tool will not find it, right? So this is to catch low-hanging fruits as part of a CI/CD, excuse me, pipelines. Okay. So I will show you an exercise, and then you can, once I'm done, you can do this exercise once again. So we are going to do the Retire.js exercise now, which helps us scan the front-end components for vulnerabilities. Okay. So this is what we're going to do. So the first thing we are going to do is install the Retire.js, and then we are going to run the Retire.js against our code base, which is specifically here package.json file. And then we are going to put this eventually in half an hour on a CI/CD pipeline so that it gets checked on a regular basis, right? So the first thing we have to do is copy the code from where we want the code which we want to scan, right? So we're going to scan this. Again, you have to click on this. If you're running this exercise on iPhone or iPad, just click on this one. If not, you can also type these commands here, like git clone, whatnot. You can clear your screen by typing Control-L or clear. You don't have to do it. Just if you want to keep it clean, then that's how you do. And then click on this. We are going to go into the web app. And then the next step, which is step 2 of 3, is to install Retire.js. So let's install this. So this is how you install it. Right? Click on this. Right? And it did install. And as you can see, it added like 30 packages. And then let's look at what the different options Retire.js provides us so that we can implement this as part of CI/CD pipeline here. Okay, as you can see, you can look at the version by -v, then it can scan Node packages on Node dependency scans only. It can run only the JavaScript files, maybe could be front-end files. And then, yeah, and then just like, safety, you can cache it locally if you want to speed up the process. Then this is how you pick it up here. And then finally, you can, let's say, imagine when you're running safety or any tool for that matter, it looks for these manifest files, be it requirements.json, requirements.txt, package.json, gem file in the current working directory. Sometimes it's not in the current working directory. So you can give the path using --js path or node path, right? And you can also just specify path like this. So it's possible that some organizations use JavaScript, but they don't use Node.js. Then you can just simply say JavaScript. Yeah, I think, and if you're behind a proxy, you can give it a proxy link. Now, eventually, we can also pick up what kind of format we want to give. If it's human who is consuming this information, maybe you want to do a text or JSON or dependency check Yeah, so this is for dependency check, which is again an amazing OAST project. It's free and still provides a lot of value. So please feel free to check that out if you want to. And you can store it on a different path if you want to using output path. You can also ignore issues if you think there is some false positives. And a word of caution or a word of maybe a suggestion here is that anyone, any vendor who sells you a project or a tool saying that it has 0 false positives, he's literally selling you on snake oil, because it's very difficult to not have false positives when you are doing static analysis, right? The technology itself is good, but then the way it works, we do some compromises. So if you want to improve speed, then you have to have less number of rule sets or less number of checks. But if you want to increase the rule sets, then it might take a lot of time for you to scan. So you have to be very careful that no matter what tool you use, paid, free, it will have false positives. So some tools give you more false positives than other, but then eventually everyone, static analysis tools, they give false positives, right? And you have to write custom rule sets, or you have to teach it saying, okay, this is a false positive, this is a real issue. So make sure you do that as well, okay? So this is what we just saw. We're going to use a couple of these options. First thing is we're going to give it the package.json. That's where our JavaScript dependencies are stored. So let me clear the screen once again. Okay, and let me check out what we have here in the manifest file, which is package.json for us. Click on that. As you can see, we are using some developer dependencies, which are used as part of development. There are some production ones. So these are the ones which goes to production. These are the ones which are used as part of development. So they don't go to prod. As you can see, there's Zap proxy here as well, if you're interested. And you can see there's a bunch of bcrypt library here, Express, which is Node.js again, MongoDB, all of these. So we're going to scan this file and see what components are vulnerable here, what needs to be updated to make them to make this project secure. Okay, so let's do that. So before you run any tool, what they want, like specifically retired.js or npm based scanners, they want those to be installed, because just like in real world, what you see probably is not what you're getting, right? What you have on the paper is probably not what you have in real life, in practice. So when you install it, it really picks up the exact versions of libraries. So then you can be assured that, yes, this library and this issue is genuine because we have installed the packages right now and then looking at those vulnerabilities. So if we just scan package.json, then probably it will have some false positives, and it's possible that it's not 100% true. Okay, so you do that. As I mentioned, if you run a command, it would be checked. So we did that, and then we're going to now run our scan, which is retire, and then we're going to give it the output format as we discussed, and we're going to give a path. So let's do that. Before that, let me clear. You don't have to clear the screen. I'm just doing for the sake of showing you. So click on this, and there you go. It's running, okay? If you're thinking it's not running, nothing is working because we are piping the output here. So let me show you the output. Retire.js, output. And as you can see, we have tons and tons of vulnerabilities here, which is pretty scary. You have to just then go bump these numbers up to fix these vulnerabilities and see. And this also provide you some information on how to fix this. Okay, what is a vulnerability? You can read about it here. So let's look at that. Let's copy this text here, copy, and then we're just gonna see what is this vulnerability. Now, there's a spelling mistake, I guess, yeah. Okay, there you go. So it says there's some dojo thingy and it has DOM-based XSS and string injection vulnerabilities. Now this guy does say that, hey, we have fixed it in 1.14. So the version you have to bump it up could be 1.14. And there's also a backported release of 1.13 as well if you want to right?
There's a question in the chat.
Sure. So I'm not sure when you joined it, but then we did discuss before that all of these files are looking for a file, a manifest file, right? So we did the exercise of a safety, which was consuming this requirements.txt file, right? And then retire.js consumes this package.json file. Okay, so this is a package file. It automatically picks it up because it's only scanning JavaScript. Now the paid tools, what they do is they basically, for a lack of, so I will keep it simple, okay? So what they do is they do something like this: list all the directories in the current working directory and pick up all manifest files. So the manifest file here is package.json, requirements.json. So imagine that you are new to, this DevSecOps or DevOps. Let's say someone came to you and they say, can you scan JavaScript packages, Java packages? Now, there are a bunch of ways how Java handles dependencies. And you can say, just Google it, right? Where does Java stores dependencies? Click on that, look at that, and you can read upon it. Like, okay, where does it store? Okay, no information here. Sorry, sir. Okay, so there is something called Maven or even Gradle. Okay, that's interesting. I'm just trying to behave like a novice. Okay, so there is this file called maven.yaml or sorry, mvn.yaml. Sorry, XML. You can tell I'm using YAML a lot. There could be ant.xml. There could be Gradle files. You can just look at there, and it will have a bunch of files which are related to Java. So we do have a OAST project called web code. Let's see where they are storing their dependencies. This is for Java because I don't know Java. I'm just I'm just being showing you around. Okay, where does this guy stores dependencies? Okay, there is something called Maven. Okay, Maven uses form.xml. So Maven around yeah, I forgot. So as you can see here, it uses one. So it's using Spring Framework version this. So it can scan. So OAS dependency checker scans for this file, looks for this file, and then does it. Similarly, retire.js here is looking for package.json. I hope that answers your question. Now, coming back to the question we have from Canada is that can we embed all of these tools as part of CI/CD pipeline and still finish within 10 to 15 minutes? Answer is yes, sir. We can run a pipeline like this, right? All of this I'm doing here, DAS, Docker security, IST, Nikto, Nmap, Docker scanning, hardening, inspect, and a bunch of other tests. And I can still finish it within 15 minutes. So this is possible. As I mentioned, we have done this with lots of our customers, clients. So yeah, possible to do. You can also do it. Okay, let's go back to the exercise. What I want all of you to do. So even though there was no package.json mentioned here, it was assumed. If there is no package.json here, let me try doing that, right? Let's for the sake of it. So let's move the package.json into this file called node modules. Let's move that. Oh, sorry. What is that? Yeah, package.json. Sorry, my bad. So let's move that to a file. Now run the exact same command. As I mentioned before, click on this, it runs the scan. Okay. Yeah, look at that. It says could not find dependencies, package.json is missing there. That's why. So if you now go into node modules and run this command by hitting up arrow, or if you're lazy like me, then just click on this button here and then we'll execute the scan. Okay. What happened there? Something, okay. But yeah, so you will see this output in retire. Looks like it did not finish the scan for some whatever reason. But let's look at. So when you do the scan again, this will open, store the results in this file here. So let's move the package.json backend again here, and then run the same command again. Click on this link here, and you will see that it did finish the scan, and we have issues here. I hope that answers your question. Okay, so you can do this here as well. So someone is asking a question. When I used dependency scanner, the OAST project, it downloaded NVD. So, but what about retired.js? It does have its own backend, and if you do, it's small. It's pretty efficient here. And how they do it. See here, there is an option here called DB somewhere. If I'm not wrong, where is it? You can either download it locally and then say that. Yeah, it's somewhere here. There's definitely, if you go to retired.js, click on the project, and they do talk about how do you update the database. There's some database here. Where was it? They do mention that here. Yeah, so there is a database actually from where it picks it up. Similarly, as I mentioned before, safety has its own database. Right? So we can update it. Yeah, so I think if I'm not wrong, there are some files which allows you to do that. And there's also a database here actually. I couldn't locate it here. Maybe they have moved it. But yeah, there is a database file which you can read and then look into it. There's definitely one. Okay, so I have another two question here. So if you look at our courses here, you also see that we are running Nmap and then we are running SSLIs. So the question is, are we running this against production and staging? So yes and no, yes and no. No, because probably your production system is not efficient enough, or it cannot take battering from these tools like Nmap. If you think it's your production environment is safe, sure, why not? Go ahead, run these tools also on production environment. But ideally, I would recommend you to first start with staging environment, because even if something goes wrong, you can still tune the tool before you can run it on production machine. So why not? What's stopping you from running those tools? Right? Before it goes to production, we can do that. Or you can do it on a maybe start up a container, do it in the test phase itself, not even the UAT as staging environment of the production. Right? So we are also doing secret scanning. If you want to learn more about it, please join our session for tomorrow and we'll look into it. Okay, I hope that answers your question. Yes, so if you're interested about what tools are run in DAST, you can check out our yesterday's presentation, and also you can also use these labs, Nmap lab, Zap, and whatnot labs to do that. Okay, so I'll take questions next afterwards. Once I'll explain you briefly about the CI/CD pipeline where we're going to embed this as part of this one. Okay, so I'll give you now 5 minutes to do this exercise, which is go here, click on the retired.js here, and I'm going to give you a link. So SCA using the retired.js link. Okay, click on here, start the exercise, and follow the instructions. It will. Okay, so we are done with the exercise, which was for retired.js. So we install retired.js now. We ran retired.js against package.json, which is a manifest file for node packages, npm packages, front-end packages. So yeah, so we found a bunch of vulnerabilities. Now it's your job to do a false positive analysis, figure out which ones are worth fixing, which ones are worth ignoring, which ones are worth putting in backlog, and then put it in some system like Jira or Bugzilla, Asana, what you have. Right, so we are done with this exercise. Now what we're going to do is we're going to put this as part of CI/CD pipeline, right? So as I mentioned before, everyone should have gotten this some unique URL for you. Okay, so please use that. Once you go in, use the password, username, password we provided you in the chat to log in into this infrastructure. Once you are there, click on this project, and you will see a file called GitLab CI file. And what we're going to do today is we are going to embed.
Just to clarify something, the passcode finishes where the word GitLab starts. So because of how Zoom chat works, they are combined together as one big sentence, but the passcode finishes where the GitLab word starts.
Okay, so now all of this can be done using commands, right? That's what we show here in other exercises. But then we are going to do with the help of UI, because some of you are not comfortable with with this one, right? So for example, I can definitely do this as part of Git commands like git add, git commit, git delete, whatever that is. So feel free to use this command, but we are going to follow a typical UI format so that it's accessible to everyone. So, okay, so we have this file called GitLab CI here. We're going to click that, edit this file. All right. And I'm going to copy a code snippet here, which is a, which is a pipeline, which I'm going to use today. Now, don't let this bother you a lot. What we are looking at the moment is specifically what we did in the labs and how is it different than that. So let's look at that. So in the lab, what we did first was we copied the code, which is automatically done by your CI/CD system. And then we installed retire.js, and then we ran the retire.js with this command here. With this command here, right? So we're going to copy exact same command of some variation of this command and put into CI/CD pipeline. As you can see here, these two stages are done by your development teams. So we are going to ignore what those are. They will already be there in your CI/CD pipelines. Now look at this here. So this exact same command we ran in our exercise here on a local machine, right? Now we just copied it here and then we are running it. Similarly, retire.js command also, we are going to run this exactly here. And then we're going to say add DevSecOps to this pipeline. Now, before that, let me open this pipeline thingy and show you. Okay, so there are no pipelines running. One pipeline ran 3 hours ago when we started this session. As I mentioned before, these things are created automatically for you, for our students to practice this concepts, right? So we did that, and we're just going to commit changes, add this file to the repository. And as soon as we did that, and you will see that it will automatically kickstart a pipeline. And here in this pipeline, we have a build stage. We also have a test stage. In that test stage, we are going to test for the front-end dependencies, vulnerabilities in front-end dependencies, and vulnerabilities in back-end dependencies. Okay, I will let this pipeline finish. So this is all being done in our lab on cloud. Okay. So as you can see, some of these jobs have kind of failed, but we still allowed them to move on. Okay, so let's look at this. OAST. Yeah, it managed to finish all of these. And then we have it stored all of these results in a file. You can download this file, open it up, you can browse this. You'll see that there is OAST results file. You can download it and consume that information. Go back again. So from a visibility perspective, this is how our jobs are configured. The build, OAST, AST, and test. We can implement so many things here if you want to. Okay, let's look at the front end vulnerabilities it found. Yes, so yeah, it couldn't do this, which is, and it couldn't find issues, so that's why it failed. So what else? What was the step which we missed here? Right? So it says could not find dependencies. So the way I fixed this, and these are the error. Yeah, no, requirements file is there. Okay, so these are some deliberate errors we introduced to teach you. Okay, what did you do? Let's go back to retire.js. So what was the first thing you did? You know, you installed retire.js. Did we do that here in the pipeline? Sorry, here. We didn't. Okay, so we have to do that. Again, whatever we teach you here, just implement that in CI/CD pipeline here, and then hit commit changes again. And as soon as you make any change to any file whatsoever, be it GitLab or any README file, this will kickstart the scans every time a developer does something. As you can see, it is running the scan. We will wait for it to finish. Now, how long does it did it took us to do this? 2 minutes, right? And I can run a full-blown pipeline on this, and it will take less than 10 minutes, including hardening, compliance, testing, ZAP. Again, baseline scan here. Don't quote me publicly wrong saying that, oh, you can run a full-blown ZAP scan within 10 minutes, okay? That I'm referring to baseline scan. Okay, so it is scanning right now. Okay, it's all done. So let's look at the front-end code. Let's see if it manages to finish it. So, oh boy, so we have some more problems in implementing this one, okay? What are we missing here? It says you don't have permissions to install the software. So you see, these are some of the problems you will face, and you have to look at the error message, try, go back, fix it. So that error which we had before of cannot find dependencies is no longer there. We solved it, but then we are given a one more issue. You have to fix this as well. That's why I was mentioning that yeah, you have to always test the setup, whatever it is, static analysis, dynamic analysis, locally first, and once you are happy with it, then put it into CI/CD pipeline, right? So that's what just happened. And as you can see, all of you can now run the script which I ran here. And there's deliberate error here. Let me see. If someone can fix it and show it, I'll probably give him something interesting. Okay, so this is the code which I'm going to paste it in the chat. You can use that to, or maybe I'll put it on, what is that? Paste bin. Okay, and all of you will be doing an exercise now. Okay, once again, you followed this exercise, and then you're embedding this as part of CI/CD pipeline. So let's do an exercise. We will have, as I mentioned, 5 minutes to do this. Go. Okay, so we have just finished the retire.js exercise in CI/CD pipeline, how you can add this integration in CI/CD pipeline. We have also seen how this pipeline can run and when it can fail, and what you can do to fix them. So this is how the pipeline looks like currently. So from past 3 days, I'm showing you free tools, and some of you said, oh, these things will not work for a paid tool, but I'm here to prove them wrong now. Okay, so let's do that. Just taking, I'm going to close this, close the pipeline. Yeah. Okay, it's stuck. Okay, fair enough. So as I mentioned before, if you are stuck at something, all you have to do is restart this. And I'm going to quickly pause my recording so that I can copy my token. This is for a paid service called Snick. I have no affiliation with them. I'm here just to show you that even paid tools can be embedded as part of CI/CD process, and they will not take more than 10 minutes of your time, or maybe forever at least. Okay, resuming back again. So the other thing we're going to do is we're going to now copy download Snick binary. So I don't have this one, so let's install duplicate. Fair enough. I'm gonna hit the up arrow. The command would be back here. Okay, I've downloaded the Snick Linux command here. As you can see here, I have a Snick Linux command. I'm just gonna rename it and add executable permissions to it, and that will turn green here, for lack of a better word, which is basically executable permissions. And I also have to install the libraries here, right? So I'm gonna say pip3 install requirements. Oh yeah, so because we did not copy the code yet, so we're gonna copy the code, go into the repository directory, and we are gonna install requirements.json. Okay, done. So we are done. So what we did are two things. We downloaded the source code, we installed Snick, or downloaded the Snick, and we also exported our key, Snick key provided by service Snick. All you have to do is just sign up for free, and you will get a token. Once you get the token, put it here, export it in environment variables and whatnot. Once you do that, what we're going to do is we're going to run now a command called snick test and hit enter, right? And before doing that, let's reduce our time and then just say, I don't want you to scan this one. I'm going to remove it temporarily. And again, snick test. Let's see what it finds. Okay, so the snick is not here because we moved it here. So, okay, I'm going to say test. Maybe we can just, let's move this snick from inside that to.
You mentioned typo again.
Oh, okay, yeah. I have this bad habit of typing snick as. Okay, so you can see now we are in the web app directory, and you have Snick here. So let's gonna do that. Let's Snick, and this is a paid tool, right? So we're gonna just run this test C. No, okay, we got an error. Interesting. Maybe because it's not using pip3. So let me do one more thing. So we are just going to scan for npm packages. So there's some issue here. So let's go ahead and go into web app directory. Web app directory. We're here. All right. As you can see, there's a package.json. Let's remove requirements.json. Sorry, txt. And then move the snick from there to here, just for the sake of ease. And let's do the command again, snick test, see if that works. Okay, so it says, oh, you don't have npm in module, so you have to install it. Okay, we will install it, sir. So we are installing the modules. And we did this in the retired.js exercise before, same stuff. And that's exactly why we did it. Why we did npm install is because of this. Okay. So it's gonna do that. Okay, there you go. That's done. Now let's try running the sneak test again. See if it, oh yeah, okay. Yes, there is a high severity issue, high, 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 medium, medium, low, and low. There you go. So even these things can be embedded as part of CI/CD pipeline. And I just showed you with the exact same steps I followed in the open source tools, same steps for the paid ones as well. Okay, so yeah, congratulations. You now know how to embed SCA as part of CI/CD pipelines or DevSecOps or DevOps pipelines, so to say. And thanks a lot once again for spending some time and spending some time and learning what is DevSecOps. If you need more information or you have any questions, feel free to reach out to me.
I have a question. So
Sure.
We didn't finish the GitLab one. So how are we going to fix that? It was asking for permission.
Yeah, it's a homework because some of you have already solved it. You have time till next week to solve it.
Okay.
Yeah. So I think, yeah, if you need to talk to me further, please reach out to me at SecFigo on LinkedIn, Twitter. Just search for SecFigo. There's only one SecFigo, and you will find me.
Also on the Slack channel, or can I message you on Slack?
Sure. Yeah, sounds good.
Thank you so much. I'll stop the recording now. Thank you, everyone. We have overrun a little bit, but I hope that's fine. It's been really, really useful. And thank you, Imran, so much, and your team.
Sure, thank you.